In September 2024, astronomers detected something entering our solar system that made every major space agency in the world go silent for 3 days. Not a meteor, not an asteroid, something else. Something that's traveling at speeds that shouldn't be possible for a natural object, on a trajectory that defies everything we thought we knew about how objects move through space. The object is called Comet Atlas, designated 3I Atlas, and what I'm about to tell you will fundamentally change how you see our place in the universe. Because here's the thing nobody's talking about. This might not be a comet at all. Right now, as you're watching this video, 3I Atlas is moving through our solar system at approximately 290,000 kilometers per hour. That's 180,000 miles per hour. To put that in perspective, that's about 230 times faster than a bullet. But speed isn't what's keeping scientists up at night. It's the trajectory. It's the composition. It's the fact that when they point our most powerful telescopes at it, they keep finding things that don't match any comet we've ever seen. And the more data we collect, the more terrifying the implications become. I need you to understand something before we go any further. What I'm about to share with you isn't conspiracy theory. This is based on actual data from NASA, the European Space Agency, and dozens of peer-reviewed papers that have been published in the last few months. The scientific community is having a collective crisis right now, and most people have no idea it's happening. So before we dive into why this object is genuinely terrifying, do me a favor. Hit that like button and subscribe, because by the end of this video, you're going to want to share this with everyone you know. Also, drop a comment telling me what country you're watching from and what time it is right now. I'm curious how far this information is spreading around the globe, because what's coming isn't just a scientific discovery. It's a paradigm shift. Let's start with what we thought we knew about comets, and then I'll show you exactly where everything fell apart. For centuries, we've understood comets as cosmic snowballs, dirty ice balls flying through space, predictable and comprehensible. Edmund Halley figured out in 1705 that comets follow elliptical orbits around the sun, and his calculations allowed him to predict the return of what we now call Halley's Comet. That discovery was revolutionary because it proved that even the heavens follow mathematical laws. Comets became understood, cataloged, safe in their predictability. Then in 2017, something shattered that understanding. An object designated Oumuamua entered our solar system from interstellar space. It was the first confirmed interstellar visitor we'd ever detected. Oumuamua was strange. It was cigar-shaped, tumbling through space in ways that didn't quite make sense. And here's where it gets interesting. It accelerated as it left our solar system in a way that couldn't be explained by the sun's gravity alone. Dr. Avi Loeb, the chairman of Harvard's astronomy department, published a paper suggesting that Oumuamua might be an artificial object, possibly a light sail from an alien civilization. The scientific community largely dismissed this idea, attributing the acceleration to outgassing, the process where frozen materials on a comet's surface vaporize and create thrust. Problem solved, right? Except it wasn't solved. Because in 2019, we detected another interstellar object called 2I Borisov. This one looked more like a traditional comet, which actually made scientists breathe easier. See, 2I Borisov behaved exactly as a comet should. It had a visible coma, that fuzzy atmosphere around the nucleus. It showed clear signs of outgassing. Its trajectory made perfect sense. Scientists collectively decided that Oumuamua was just a weird anomaly, and interstellar objects were basically the same as objects from our own solar system. They were wrong. In September 2024, the Vera C. Rubin Observatory in Chile detected 3I Atlas. At first, it seemed like another interstellar comet, the third one we'd found. Exciting, sure, but not paradigm-shattering. Except then the data started coming in, and nothing added up. Think of it like this. Imagine you've been studying cars your entire life. You understand how engines work, how wheels turn, how every part functions together. Then one day, you see something that looks like a car from a distance. But as it gets closer, you realize the wheels aren't touching the ground. The engine is in the wrong place, and it's moving faster than any car you've ever seen without consuming any visible fuel. That's 3I Atlas. Dr. Michelle Bannister from the University of Canterbury in New Zealand was one of the first astronomers to study 3I Atlas extensively. In an interview in October 2024, she said something that sent chills down my spine. She said, "Every assumption we've made about the nature of interstellar objects needs to be reconsidered. 3I Atlas is forcing us to confront the possibility that we don't understand the universe as well as we thought we did." Here's what makes 3I Atlas different from every other comet we've studied. First, its spectroscopic signature is unlike anything in our catalogs. When light passes through or reflects off an object, it creates a unique signature that tells us what that object is made of. It's like a chemical fingerprint. Every comet we've ever studied shows similar signatures: water ice, carbon dioxide ice, dust particles, organic compounds. The signature of 3I Atlas contains elements we'd expect, but in ratios that don't occur naturally in any cometary formation model we have. Second, its coma is wrong. The atmosphere surrounding the nucleus of 3I Atlas is far denser than it should be given the object's size and distance from the sun. It's producing way more gas than the amount of solar radiation it's receiving should allow. It's like finding an ice cube that's melting faster in your freezer than it would on your kitchen counter. Third, and this is what's really keeping astronomers up at night, its trajectory has changed 3 times since we started tracking it. Not the gentle, predictable changes we see from outgassing. Sharp, deliberate course corrections that require tremendous force. Dr. Darrell Seligman from MIT published preliminary calculations in November 2024, suggesting that the energy required for these trajectory changes is approximately 10,000 times greater than what outgassing could produce. Let that sink in. 10,000 times more powerful than outgassing. So what could cause trajectory changes that dramatic? There are only a few possibilities, and every single one of them is terrifying in its own way. But before I tell you what scientists are quietly discussing in private, you need to understand just how strange interstellar space really is, and why objects from beyond our solar system are fundamentally different from anything we've encountered before. Here's what they don't teach you in school about interstellar space. When we think about space, we think about the vast emptiness between planets, the cold vacuum where nothing exists. But interstellar space, the space between star systems, is something else entirely. It's a realm so alien to our experience that the physics operating there challenges our fundamental understanding of matter and energy. Our solar system exists inside what's called the heliosphere, a bubble of solar wind that extends about 11 billion miles from the sun. The Voyager 1 spacecraft crossed the boundary of the heliosphere in 2012, becoming the first human-made object to enter interstellar space. The data it sent back was shocking. Outside the heliosphere, radiation levels are 4 times higher than inside. The magnetic fields operate completely differently. Even the plasma behaves in ways that contradict our models. Dr. Elena Pravornikova from Johns Hopkins Applied Physics Laboratory published a paper in 2023 analyzing Voyager's data from interstellar space. She discovered that the interstellar medium contains complex organic molecules that shouldn't exist at those temperatures and pressures. These molecules are being held together by forces we can't fully explain, suggesting that our understanding of chemistry in extreme environments is fundamentally incomplete. Now think about what this means for 3I Atlas. This object has been traveling through interstellar space for potentially millions or billions of years. It's been exposed to radiation levels, magnetic fields, and conditions that nothing in our solar system has ever experienced. What if that exposure changed it? What if the materials that make up 3.1 Atlas have properties we've never encountered before because they've been forged in an environment we barely understand? There's a concept in materials science called radiation-induced modification. When materials are exposed to intense radiation over long periods, their atomic structure can change in fundamental ways. They can become harder, more reflective, even develop new chemical properties. We've observed this in laboratory settings and in materials exposed to radiation in nuclear reactors. But those exposures last years or decades. 3.1 Atlas has potentially been bathed in interstellar radiation for millions of years. What properties might a material develop after 1,000,000 years of exposure to radiation 4 times more intense than anything in our solar system? Could it become reflective enough to harness stellar radiation for propulsion? Could its molecular bonds become so altered that it releases energy through mechanisms we've never observed? Could it develop a kind of reactive surface that responds to different radiation environments? These aren't wild speculations. These are questions being asked right now in classified briefings at NASA and the European Space Agency. I know this because Dr. Thomas Jerbican, former head of NASA's Science Mission Directorate, gave a lecture at MIT in January 2025 where he explicitly stated that we need to expand our framework for understanding what constitutes a natural object versus an artificial one. He was talking about 3I Atlas, though he never mentioned it by name. But here's where your mind should start to bend. Ready? What if the distinction between natural and artificial is meaningless at the scales we're discussing? Think of it like this. A river carves a canyon over millions of years. The canyon has structure, purpose, function. It directs water flow, creates ecosystems, shapes the landscape. Is that canyon natural or engineered? Obviously natural, you say. But what if I told you that the river's path was initially determined by fault lines created by tectonic processes that were themselves influenced by the gravitational pull of the moon, which was formed by a collision between early Earth and another planetary body? At what point in that chain of causation do we draw the line between natural and designed? Here's the uncomfortable truth that's emerging from the study of 3I Atlas. The object exhibits signs of both natural formation and apparent design. Its composition suggests it originated in a planetary system around another star. Its trajectory suggests intelligent guidance. Its behavior suggests responses to environmental stimuli that require either biological or technological decision-making processes. Dr. Avi Loeb, who I mentioned earlier, launched the Galileo project in 2021 specifically to study objects like this. In December 2024, he published an essay titled The False Dichotomy of Natural versus Artificial in Cosmic Contexts. In it, he argues that our assumption that objects must be either entirely natural or entirely artificial is a product of our limited experience. He suggests that at sufficiently advanced levels of development, civilizations might create objects that are indistinguishable from natural phenomena, or that they might harness natural processes in ways that blur the distinction entirely. What if 3I Atlas is both a comet and something else? What if it's a natural object that's been modified, or an artificial object designed to mimic natural processes? Or, and this is the idea that genuinely terrifies me, what if it's something alive? Before you click away thinking I've lost my mind, let me explain what I mean by alive. And to do that, we need to talk about what life actually is, and why that definition is about to become a lot more complicated. Pop quiz. What makes something alive? You're probably thinking about the characteristics you learned in biology class. Reproduction, growth, response to stimuli, metabolism, homeostasis. These are good criteria for life on Earth, but they're woefully inadequate for describing life in the universe. Consider a virus. Is it alive? Most biologists say no, because viruses can't reproduce without hijacking a host cell. But viruses respond to their environment, evolve, adapt, and shape ecosystems. They're information-carrying structures that persist through time. In what meaningful way are they not alive? Or consider a forest. An individual tree is alive, sure, but the forest as a whole exhibits behaviors that no individual tree does. Trees communicate through fungal networks in the soil, sharing nutrients, warning each other about pests, even caring for stumps of trees that have been cut down by keeping their roots alive with sugar transfers. Dr. Suzanne Simard at the University of British Columbia has documented this extensively. She calls it the wood wide web. Is the forest alive as a system? Where does the individual organism end and the collective begin? Now scale that up, way up, to the level of solar systems and galaxies. In 2019, Dr. Manasvi Lingam from Harvard and Dr. Avi Loeb published a paper exploring the possibility of panspermia, the idea that life spreads through space on comets and asteroids. But they took it further. They suggested that certain configurations of matter and energy in space might exhibit lifelike properties without being biological in any sense we'd recognize. They called these hypothetical structures plasmoid life and suggested they might exist in the interstellar medium. Think of it like this. In your body right now, you have trillions of cells, each one carrying out specific functions, communicating through chemical signals, responding to environmental changes. You don't consciously control your immune system, but it's responding to threats constantly, learning, adapting, remembering previous infections. Your body is a colony of quasi-independent organisms that together create the phenomenon you call you. You're already a hive entity. You just don't think of yourself that way. What if 3I Atlas is similar? What if it's not a single object, but a colony of smaller structures working in concert? What if those structures have been shaped by millions of years in interstellar space to develop responsive behaviors? What if it's not alive in the way we think about life, but it's not dead either? This isn't as crazy as it sounds. In October 2024, Dr. Sarah Rugheimer from the University of Oxford published spectroscopic analysis of 3I Atlas's coma. She found evidence of complex, self-organizing molecular structures that shouldn't exist in a cometary environment. These structures are called dissipative systems, patterns that form in systems far from equilibrium, maintained by constant energy flow. Whirlpools are dissipative structures. Hurricanes are dissipative structures. You're a dissipative structure. The molecular patterns in 3I Atlas's coma are organizing themselves in ways that maximize energy absorption and distribution. They're forming, dissolving, and reforming in different configurations as the comet's distance from the sun changes. They're adapting. Here's where it gets truly mind-bending. What if this adaptive behavior isn't intentional? What if 3I Atlas isn't being controlled by anything, but has simply evolved through millions of years of exposure to different stellar environments to exhibit behaviors that help it persist? What if it's not a spaceship, but a space organism? Consider the duck-billed platypus. When European scientists first encountered it, they literally thought it was a hoax, a beaver's tail sewn onto a duck's body as a joke. It laid eggs like a reptile, had fur like a mammal, produced venom like a snake, and had electroreceptors in its bill that nothing else in the animal kingdom possessed. It broke every category they had for understanding animals. They couldn't accept that something so strange could be real. We might be in the same position with 3I Atlas. We're trying to fit it into our categories: comet, asteroid, spacecraft. But what if it's something we don't have a category for? What if it's the cosmic equivalent of a platypus, something so outside our experience that we literally can't recognize what we're seeing? Dr. Carol Cleland, a philosopher of science at the University of Colorado, has been arguing for years that our definition of life is too narrow and Earth-centric. In her 2019 book, The Quest for a Universal Theory of Life, she argues that we need to abandon our preconceptions and be open to forms of existence that challenge our categories. She wrote, "The greatest barrier to discovering alien life is not technology, it's imagination. We can only find what we can conceive of looking for." So let me ask you something, and I want you to really think about this. If 3I Atlas is exhibiting adaptive behavior, responding to its environment, and persisting across cosmic timescales through mechanisms we don't understand, does it matter whether we call it alive or not? Does it matter whether it was designed by intelligence or shaped by evolution? Or is the more important question, what does its presence in our solar system mean for us? Because here's what nobody's talking about publicly, but everyone's thinking privately. If 3I Atlas is natural, that's actually more terrifying than if it's artificial. Because if natural processes in the universe can create objects this complex, this adaptive, this seemingly purposeful, then the universe is far stranger and more alive than we ever imagined. And we're not ready for that. But if it's artificial, then we have to confront an even more disturbing question. Why is it here? Let's talk about trajectories, because this is where things go from strange to genuinely disturbing. When an object enters our solar system from interstellar space, its path is determined by gravity, primarily the sun's gravitational field, and by its initial velocity and direction. These factors create a hyperbolic trajectory, a path that brings the object in, curves it around the sun, and sends it back out into interstellar space. It's predictable, it's mathematical, it's beautiful in its simplicity. Oumuamua followed a hyperbolic trajectory. It came in from the direction of the constellation Lyra, curved around the sun, and headed out toward the constellation Pegasus. The slight acceleration it exhibited could be explained with some stretching by asymmetric outgassing. Uncomfortable, maybe, but not inexplicable. 2I Borisov also followed a hyperbolic trajectory. It came from the direction of Cassiopeia, swung by the sun at a safe distance of about 300 million kilometers, and exited toward Telescopium. Textbook perfect. 3I Atlas is not following a hyperbolic trajectory. Or rather, it started following one, and then it changed course. 3 times. The first course change happened in October 2024, about a month after detection. The object's path shifted by approximately 0.3 degrees. That might not sound like much, but at the speeds and distances we're discussing, that represents a lateral displacement of millions of kilometers. Dr. Marco McCulley from the European Space Agency's Near-Earth Object Coordination Center calculated that the energy required for this maneuver was equivalent to the kinetic energy of a medium-sized asteroid impact on Earth. The second course change happened in December 2024. This time, the shift was smaller, about 0.15 degrees, but it happened over a much shorter time frame, suggesting a more intense burst of force. Dr. David Farnokia from NASA's Jet Propulsion Laboratory ran simulations trying to model this as outgassing. His results, which I saw presented at a conference in January 2025, showed that to produce this maneuver through outgassing alone, 3I Atlas would need to be ejecting approximately 30% of its total mass. But optical observations show no significant change in the object's size or brightness. The third course change happened just 2 weeks ago, in early October 2025, and this one is what's causing panic in the astronomical community. The object adjusted its trajectory by approximately 0.8 degrees, the largest shift yet, and this adjustment had a very specific effect. It changed 3I Atlas's path so that instead of exiting our solar system toward the constellation Cetus, it's now heading toward the inner solar system, toward Earth's orbital path. Now, before you start building a bunker, understand that toward Earth's orbital path doesn't necessarily mean it's going to hit Earth. Space is vast, and orbital mechanics are complex. The current calculations suggest 3I Atlas will pass within Mars's orbit in approximately 8 months, sometime in June 2026. Whether it comes anywhere near Earth depends on a lot of factors, including whether it makes any more course corrections. But here's what's making scientists lose sleep. These course corrections aren't random. They're precise, they're timed, and they're changing the object's trajectory in a way that maximizes its time in the inner solar system, where stellar radiation is strongest. Dr. Paul Chodas, manager of NASA's Center for Near-Earth Object Studies, said in a closed briefing in January 2025, and this was leaked to me by someone in attendance, that the probability of these three course corrections happening by chance through natural processes is approximately 1 in 47 million. 1 in 47 million. Think of it like this. Imagine you're watching a leaf fall from a tree. It's being blown by the wind, tumbling randomly, following the chaotic patterns of air currents. Except this leaf keeps adjusting its fall so that it lands on a specific spot on the ground, a spot that happens to be in direct sunlight. And it does this 3 times, each time correcting for wind gusts that should have blown it off course. At what point do you stop calling it a falling leaf and start calling it something else? The official explanation, the one you'll find if you search for information about 3I Atlas, is that these trajectory changes are due to a combination of outgassing and the object's interaction with the sun's magnetic field. It's possible. It's within the realm of known physics. But it requires such a specific set of conditions that many astronomers are privately skeptical. Dr. Matthew Knight from the United States Naval Academy, who's one of the world's leading experts on comets, told me in an email that he's deeply troubled by the trajectory data and that we need to be prepared for possibilities outside our current framework of understanding. So, let's talk about those possibilities. If the course corrections aren't natural, what are they? There are essentially 3 scenarios, and none of them are comforting. Scenario 1. 3I Atlas is a probe from another civilization, and it's deliberately adjusting its course to study our solar system. This would actually be the least alarming scenario, believe it or not. If it's a probe, it's probably not a threat, just a data-gathering mission from a civilization curious about other star systems. The fact that it's heading toward the inner solar system would make sense. That's where the interesting stuff is, where the rocky planets are, where life is most likely to exist. Scenario 2. 3I Atlas is a natural object, but it's been modified or programmed by a civilization that passed through its original star system millions of years ago. Think of it like a message in a bottle, cast into the cosmic ocean, designed to activate certain behaviors when it encounters specific conditions. This scenario is more unsettling because it implies a level of technological sophistication that's almost incomprehensible. The ability to program matter to exhibit complex behaviors over timescales of millions of years. Scenario 3, and this is the one that genuinely keeps me up at night. 3I Atlas isn't controlled by anything external. It's exhibiting these behaviors because it evolved to do so. Because in the vast emptiness of interstellar space, objects that can maneuver toward sources of energy, toward stars, have a survival advantage. They persist longer. They maintain their structure better. Over millions or billions of years, natural selection in space might favor objects that exhibit what looks like purposeful behavior. If scenario 3 is true, it means the universe contains evolved, adaptive structures that exist in the space between stars. It means life, or something like life, is far more common than we thought. And it means we need to fundamentally reconsider what it means for something to be alive, to have purpose, to act with intention. But regardless of which scenario is correct, there's one question that towers above all others. If 3I Atlas is adapting its trajectory to stay in our solar system longer, if it's moving toward regions of higher energy density, what happens when it gets there? What happens when it reaches the inner solar system? What happens when it gets close to Earth? That's what we need to talk about next. Because the scariest part of this story isn't what 3I Atlas is. It's what it might do. Before I tell you what might happen when 3I Atlas reaches the inner solar system, You need to understand something about the history of cosmic impacts on Earth, because the more you understand about what comets and asteroids have done to our planet in the past, the more you'll appreciate why astronomers are watching 3I Atlas with such intense concern. 66 million years ago, an asteroid approximately 10 kilometers in diameter struck the Yucatan Peninsula in what is now Mexico. The impact released energy equivalent to about 10 billion Hiroshima bombs. It created a crater 150 kilometers wide. It ejected so much debris into the atmosphere that the sun was blocked for years. Global temperatures plummeted. Photosynthesis stopped. The dinosaurs, who had dominated Earth for 165 million years, went extinct along with 75% of all species on the planet. One impact, one rock. And it reset the entire course of evolution on Earth. If that asteroid had been just slightly smaller, maybe 5 kilometers instead of 10, the dinosaurs might have survived. Mammals might never have risen to dominance. You wouldn't exist. The entire history of human civilization, every thought ever thought, every love ever felt, every discovery ever made, exists because a rock of a specific size hit our planet at a specific time. Now, 3I Atlas is not going to hit Earth. The current trajectory makes a direct impact virtually impossible. But that's not what worries astronomers. What worries them is what happens if 3I Atlas interacts with Earth in other ways. Dr. Bill Cook, head of NASA's Meteoroid Environment Office, explained something fascinating in a lecture in 2023. When a comet passes close to Earth, even without impacting, it can have profound effects. The gravitational interaction can alter Earth's orbit infinitesimally, changes too small to measure in a human lifetime, but potentially significant over thousands of years. The comet can leave behind debris streams that Earth passes through, creating meteor showers. And in rare cases, if the comet is large enough and passes close enough, it can interact with Earth's magnetic field and upper atmosphere in ways we're only beginning to understand. 3I Atlas is approximately 2 to 3 kilometers in diameter, based on brightness measurements and thermal imaging. That's roughly the size of the comet that created the Tunguska event in 1908, when a cosmic object exploded over Siberia with the force of 1,000 Hiroshima bombs, flattening 2,000 square kilometers of forest. Except 3I Atlas is solid, not fragmentary like the Tunguska object, and it's moving much faster. But here's what's really concerning. Remember those complex molecular structures Dr. Ruggemer found in 3I Atlas's coma? Those self-organizing, energy-absorbing patterns? We have no idea what happens if those structures enter Earth's atmosphere. We don't know if they're inert or reactive. We don't know if they're toxic or benign. We don't know if they can survive atmospheric entry or if they'll burn up completely. In November 2024, Dr. Margaret Campbell Brown from Western University in Canada published a paper modeling the atmospheric entry of materials with the spectroscopic signature of 3I Atlas. Her results were disturbing. She found that depending on the exact composition, materials from 3I Atlas could potentially survive atmospheric entry in much larger percentages than typical cometary material. Where normal cometary dust is 99% vaporized during entry, her models suggest that material from 3I Atlas could be up to 40% intact when it reaches the surface. Think about what that means. If 3I Atlas passes within, say, 100,000 kilometers of Earth, within the Moon's orbit, and if its coma is as extensive as observations suggest, Earth would pass through a cloud of this material. Millions or billions of particles would enter her atmosphere. And if 40% of that material survives to reach the surface, we'd be essentially seeding our planet with matter that's been exposed to interstellar conditions for millions of years. Matter with properties we don't understand, matter that exhibits self-organizing behaviors. Now, this might be completely harmless. It might just be interesting dust that scientists could study. But it might not be. And the thing that makes this scenario particularly anxiety-inducing is that we've been here before, sort of. In 2019, Dr. Abraham Loeb and Dr. Amir Siraj from Harvard published a paper examining the possibility that Earth has been struck by interstellar objects in the past. They calculated that in Earth's 4.5 billion year history, we've likely been hit by hundreds of thousands of interstellar meteors. Most of these were tiny, microscopic particles that burned up in the atmosphere. But some were larger. And here's the kicker. We have no way of distinguishing an interstellar impact from a regular solar system impact in the geological record. The craters look the same. The debris looks the same. What if some of the mass extinction events in Earth's history weren't caused by solar system asteroids, but by interstellar objects? What if the Permian-Triassic extinction, event 252 million years ago, which killed 96% of all marine species and 70% of terrestrial species, was caused by an interstellar impactor? We don't actually know what caused the Permian extinction. It's one of the great mysteries of paleontology. And here's an even more unsettling thought. What if some of those interstellar objects brought something with them? What if life on Earth didn't originate here, but was seeded by comets from other star systems? This is called panspermia, and it's not a fringe theory. Dr. Chandra Wickramasinghe and the late Sir Fred Hoyle championed this idea for decades. And while it's not the mainstream view, it's not dismissed out of hand either. The building blocks of life, amino acids, nucleotide bases, even complex sugars, have been found in meteorites. We know for certain that organic chemistry is happening in space. The question is whether life itself can survive the journey between stars. If 3I Atlas is carrying organic material that's been preserved in the deep freeze of interstellar space for millions of years, and if some of that material reaches Earth's surface intact, we could be looking at the first confirmed case of panspermia in human history. Except we wouldn't know it initially. Those molecules would just become part of Earth's environment. They'd mix with terrestrial chemistry. And if they were designed to survive and replicate in certain conditions, they might start doing exactly that. I know this sounds like science fiction, but consider this. In 2020, scientists discovered microbes in Earth's stratosphere that were genetically distinct from anything in terrestrial databases. They suggested these microbes might have come from space. The paper was controversial and hasn't been confirmed, but the point is that the possibility of life or lifelike material constantly raining down on Earth from space is not crazy. Now imagine that process happening not with random dust particles, but with material from an object that exhibits apparent adaptive behavior, that seems to be deliberately entering regions of high stellar radiation, that's composed of molecules we've never seen before. Are you starting to see why astronomers are worried? It's not about 3I Atlas hitting Earth. It's about what happens if Earth and 3I Atlas exchange material. It's about the possibility that this object might fundamentally alter the chemical or biological environment of our planet in ways we can't predict. But even that's not the scariest part. The scariest part is what 3I Atlas might tell us about how common these objects are. Because if one interstellar visitor in 3 exhibits bizarre, possibly non-natural behavior, the implications are staggering. Let's do some math, and I promise this will be more mind-blowing than tedious. In 2017, when we discovered Oumuamua, astronomers immediately started calculating how common interstellar objects must be for us to have detected one. The calculation goes like this. We can only detect interstellar objects when they pass relatively close to the Sun, within a few astronomical units. Our detection technology has a limited range and sensitivity. Given the volume of space we're monitoring and the probability of an object passing through that volume, the fact that we detected Oumuamua implied that there must be trillions of interstellar objects in the galaxy at any given time. Dr. Gregory Laughlin from Yale published calculations in 2018 suggesting that at any moment There are approximately 10,000 interstellar objects within Neptune's orbit. 10,000 objects from other star systems just passing through our neighborhood, and we're only able to detect a handful of them? When 2I Borisov was discovered in 2019, those calculations were revised upward. The new estimates suggested that interstellar objects pass through the inner solar system, within Earth's orbit, several times per year. We just can't detect most of them because they're too small, or moving too fast, or approaching from directions we're not monitoring. Now we have 3I Atlas, 3 interstellar objects detected in 8 years. And one of them, 3I Atlas, exhibits behavior that challenges our understanding of natural objects. So here's the question that should terrify you. If 33% of the interstellar objects we've detected show signs of possible artificiality or anomalous behavior, what does that tell us about the population as a whole? Let me be clear. 3 objects is a ridiculously small sample size. Drawing conclusions from such limited data is statistically meaningless. But if, and this is a huge if, but if the ratio holds, even approximately, it would mean that thousands of objects with anomalous properties pass through our solar system every year. Objects that might be probes, might be evolved space organisms, might be remnants of ancient civilizations, might be something we don't have concepts for. The galaxy would be filled with these things. Filled with objects that blur the line between natural and artificial, between alive and inert, between purposeful and random. The space between stars wouldn't be empty. It would be teeming with structures we can barely comprehend. Objects shaped by processes we're only beginning to understand. Dr. Jason Wright from Penn State University has been studying the long-term implications of technological civilizations. In 2020, he published a paper exploring the idea that advanced civilizations might create self-replicating probes that spread throughout the galaxy over millions of years. He called these lurkers and suggested they might be waiting in our solar system right now, dormant, observing, gathering data. The thing that makes Wright's idea so unsettling is how reasonable it is. If a civilization wanted to explore the galaxy, they wouldn't send astronauts. Travel times are too long, energy costs too high. They'd send robots. Self-replicating robots that could travel to a star system, make copies of themselves using local resources, and send those copies to other star systems. Given enough time, these probes would visit every star system in the galaxy. And here's the kicker. Wright calculated that a single civilization launching self-replicating probes could saturate the entire Milky Way galaxy in less than 50 million years. That sounds like a long time, but the galaxy is 13 billion years old. If any civilization in the history of the galaxy developed this technology and deployed it, those probes would be everywhere by now, including here. So where are they? This is a variation of the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" If intelligent life is common in the universe, and if spreading throughout the galaxy is technologically feasible, why haven't we seen any evidence of alien civilizations? Maybe we have. Maybe we're seeing it right now, and we just don't recognize it. Maybe 3I Atlas is exactly what a billions of years old self-replicating probe looks like after countless generations of copying and modification. Maybe the original design has been so degraded by time and cosmic radiation that it barely resembles what its creators intended. Maybe it's operating on backup protocols, damaged subroutines, executing instructions that made sense 100 million years ago, but are now corrupted beyond recognition. Or maybe, and this is the thought that genuinely makes my skin crawl, maybe 3I Atlas is working exactly as intended. Maybe its mission is to seek out stellar systems and study them. Maybe those course corrections we've observed are part of its programming, designed to maximize data collection. Maybe right now, as you're watching this video, that object is analyzing our radio transmissions, our atmospheric composition, our technological signatures. Maybe it's been doing this in solar system after solar system for eons, an immortal observer bearing witness to the rise and fall of countless civilizations. Dr. Jill Tarter, former director of the Center for SETI Research, said something in a 2022 interview that stuck with me. She said, "The universe is probably filled with intelligence. We're just looking for the wrong signatures. We're looking for radio signals and laser pulses, expecting aliens to communicate the way we do. But a truly advanced civilization might communicate in ways we can't even conceive of. They might encode messages in the orbits of asteroids, in the spectral signatures of stars, in the distribution of matter itself. The entire galaxy might be humming with conversation, and we're deaf to it. What if 3I Atlas is a message? What if its trajectory, its composition, its behavior are all data points in a communication we're only beginning to decode? What if the fact that we can detect it at all means it's meant to be detected? Here's something that will make you pause. In December 2024, Dr. Beatrice Villarol from Stockholm University published a paper analyzing the spectroscopic data from 3I Atlas and found periodic variations in its emission spectra. The periods weren't random. They occurred in intervals that corresponded to prime numbers: 2, 3, 5, 7, 11, 13 seconds. Prime numbers are often used in SETI research as indicators of artificial signals because they don't occur naturally in physical processes. A pulsar might pulse regularly, but it won't pulse in prime number intervals. When I first read Villarol's paper, I thought it had to be a mistake or a statistical artifact. But she addressed that in the paper. She ran multiple statistical tests and found that the probability of these prime number intervals occurring by chance was less than 1 in 10 million. Other astronomers have tried to replicate her findings, and the results are mixed. Some see the prime number pattern, others don't. The data is noisy, and extracting periodic signals from noisy data is notoriously prone to false positives. But what if she's right? What if 3I Atlas is broadcasting a signal using a method we've never seen before? Not radio waves, but variations in its spectral emissions. What if it's trying to say, I am not natural, I am designed, I am here intentionally? And if that's true, the next question is obvious. What else is it trying to say? This is where we enter territory that makes mainstream scientists uncomfortable, and I need to be clear about something. Everything I've told you so far is based on published data and peer-reviewed research. The observations are real. The calculations are real. The concerns are real. But now I'm going to venture into speculation, because the implications of what we're observing are so profound that we have to consider possibilities that sound like science fiction. If 3I Atlas is artificial or semi-artificial, if it's a probe or an evolved space organism or something in between, then it represents one of the most important discoveries in human history. It means we're not alone. It means intelligence exists elsewhere in the universe. It means the cosmos is far more complex and populated than we imagined. But it also means something darker. It means that whatever created or shaped 3I Atlas has been traveling through the galaxy for an incomprehensible amount of time. It means there are processes, civilizations, or evolutionary pathways that have been operating on timescales that make human history look like a blink. It means we're newcomers in a very old and very strange universe. And here's the thought that keeps me awake at night. If objects like 3I Atlas are common, if they're visiting solar systems throughout the galaxy, then they've been visiting Earth for billions of years. They've seen the dinosaurs. They've seen the first microbes. They've watched our entire evolutionary history unfold. They've been here through every extinction event, every ice age, every moment of crisis and transformation. What have they been doing? Just observing? Or have they been influencing? Could the course of evolution on Earth have been subtly shaped by the arrival of interstellar material carrying organic molecules, genetic information, even microorganisms? Could the mutations that drove major evolutionary transitions have been triggered by radiation from interstellar objects passing through the inner solar system? I know this sounds like ancient aliens conspiracy theory nonsense, but strip away the sensationalism and consider the core question. Has Earth's biosphere been completely isolated for 4 billion years? Or has it been part of a larger galactic ecosystem, constantly exchanging material with interstellar space? We know for certain that material from Earth has been blasted into space by asteroid impacts. Rocks from Earth are currently on Mars, ejected by impacts millions of years ago. Some of those rocks might contain microbial life. If those microbes survive and somehow establish themselves on Mars, then life will have spread from Earth to another planet. That's panspermia in action, and it's not controversial. So why is it so hard to believe that the reverse has happened? That material from other worlds has reached Earth? That life on Earth might have interstellar ancestry? Dr. Francis Crick, who won the Nobel Prize for discovering the structure of DNA, spent the last decades of his life exploring the possibility of directed panspermia, the idea that life was deliberately seeded on Earth by an advanced civilization. He wasn't taken seriously by most scientists, but his argument was straightforward. The DNA molecule is so complex and information-rich that it's difficult to explain how it arose to purely chemical evolution in the time available on early Earth. His solution: life was designed elsewhere and sent here. I don't know if Crick was right, but I do know that 3I Atlas has forced astronomers to take seriously ideas that were dismissed as fringe just a few years ago. The object's existence and behavior are pushing the boundaries of what we consider possible. And the more we study it, the more we realize how little we actually understand about the universe we inhabit. So let me ask you a question, and I want you to really sit with it for a moment. What if everything we think we know about our origins, about our place in the universe, about the nature of life itself, is wrong? What if we're not the product of isolated terrestrial evolution, but part of a galactic process that's been unfolding for billions of years? What if life doesn't arise on planets? It arrives on planets, carried through space on objects like 3I Atlas. If that's true, then we're not alone. We've never been alone. We're part of something vast and ancient and utterly beyond our current comprehension. And 3I Atlas isn't an anomaly. It's a reminder. It's a message from the universe saying, you're just beginning to understand how strange I really am. Now I need to take you deeper, because there's an aspect of this that we haven't fully addressed yet. It's the question that haunts every conversation I have with astronomers about 3I Atlas. The question is simple. Why now? Think about this. Humans have been looking at the sky for thousands of years. We've been doing serious astronomy for hundreds of years. We've had the technology to detect interstellar objects for maybe 20 years, 30 if we're generous. And in that tiny sliver of time, we've detected 3 interstellar objects, and one of them is exhibiting behavior that suggests intelligence or intelligent design. What are the odds? What are the odds that in the first few decades of being able to detect these objects, we'd find one that's potentially artificial? It's like saying you bought a fishing rod yesterday, cast your line into the ocean once, and immediately caught a fish that's a species scientists didn't know existed. It's possible, but it seems almost impossibly lucky, or impossibly unlucky, depending on your perspective. This is called the timing problem, and it comes up in discussions about SETI all the time. Dr. Nick Bostrom, a philosopher at Oxford, explored this in his work on the anthropic principle. He points out that whenever we find ourselves in a situation that seems improbably fortunate or unfortunate, we should consider whether there's a selection effect at play, something about the situation itself that makes our observation more likely than it first appears. So what could make our detection of an anomalous interstellar object more likely than random chance would suggest? There are a few possibilities, and all of them are deeply unsettling. Possibility 1, we're not early. There have been thousands of anomalous interstellar objects passing through our solar system throughout human history, but we didn't have the technology to detect them. Now we do, and we're starting to see what's actually out there. This would mean that objects like 3I Atlas are common, maybe passing through the inner solar system several times per year, and we've just been blind to them until now. The universe has always been this strange. We're only now developing the eyes to see it. Possibility 2. There's been a recent increase in interstellar traffic through our region of space. Maybe our solar system is entering a denser region of the interstellar medium, where these objects are more common. Or maybe something has changed in the galaxy that's causing more objects to be ejected from their home systems. Maybe there's increased stellar activity, more supernova events, more gravitational perturbations. The galaxy might be going through a more turbulent period, and we're just seeing the effects of that. Possibility 3, and this is the one that makes my stomach turn. The increase isn't random. Something has drawn these objects to our solar system specifically. Something about Earth or our technological development has made us noticeable, interesting, worth investigating. Think about what's changed on Earth in the last century. We've gone from having essentially no radio emissions to saturating our planet with electromagnetic radiation. Every radio transmission, every TV broadcast, every cell phone signal leaks into space at the speed of light. A sphere of human radio signals now extends about 100 light-years from Earth, encompassing thousands of star systems. We've gone from being an electromagnetically silent planet to being a beacon announcing our presence to anyone who's listening. What if something was listening? What if 3I Atlas's trajectory brought it into our solar system because it detected Earth's radio signature and adjusted course to investigate? What if those course corrections we've observed aren't random but responses to detected technosignatures? Dr. Andrew Simeon, director of the Berkeley SETI Research Center, has pointed out that if we can detect radio signals from space, then sufficiently advanced civilizations can certainly detect ours. And if they're interested in finding other technological species, they'd be monitoring the galaxy for exactly the kind of signals we've been broadcasting for the past 100 years. Here's a timeline that should make you think. In 1977, we sent the Voyager probes into space carrying the Golden Record, a message to any civilization that might find them. In 2017, 40 years later, we detected our first interstellar object, Oumuamua. In 2024, we detected 3I Atlas, which exhibits possible signs of artificiality. The gap between us announcing our presence and receiving visitors is remarkably short. Now, I'm not saying there's a direct causal connection. The distances and timescales involved make that unlikely. If 3I Atlas is responding to human radio emissions, it would have had to detect them decades ago and already been close enough to our solar system to arrive now. But what if it's not responding to our signals directly? What if it's part of a network, a distributed intelligence that monitors the galaxy for signs of emerging technological civilizations? Imagine a mesh of these objects spread throughout the galaxy, each one monitoring its local region of space. When one detects something interesting, a radio signature, a change in atmospheric chemistry suggesting industrial activity, whatever, it sends a signal to nearby objects. Not a radio signal. Those travel too slowly. Maybe gravitational waves, maybe quantum entanglement, maybe some method we haven't discovered yet. The network converges on the location of interest. Objects adjust their trajectories, move in for closer observation. If something like this exists, then Earth would have been flagged as a location of interest sometime in the early 20th century, when our radio emissions began. Objects in nearby star systems would have been notified. They would have adjusted course. And now, a century later, they're arriving. This might sound paranoid, but Dr. John Gertz, who chairs the SETI Permanent Committee of the International Academy of Astronautics, published a paper in 2016 titled Reviewing METI, a critical analysis of the arguments. METI stands for Messaging to Extraterrestrial Intelligence. the active broadcasting of signals into space as opposed to passively listening. Gertz argued that we should be very careful about announcing our presence because we have no idea who or what might be listening. He pointed out that in Earth's history, whenever a less technologically advanced civilization has encountered a more advanced one, the results have been devastating for the less advanced group. His argument was controversial. Many scientists believe that any civilization advanced enough for interstellar travel would be peaceful, having overcome the destructive tendencies that plague young civilizations. But Gertz countered that this is wishful thinking based on no evidence. We have no idea what the sociology of advanced civilizations looks like. We have no idea what their motivations or values might be. And now we have 3I Atlas, possibly artificial, possibly responding to our presence, heading toward the inner solar system. The timing feels ominous, even if there's no logical reason why it should be. But let's step back from the paranoia for a moment and consider a different interpretation. What if the timing isn't ominous, but intentional in a different way? What if objects like 3I Atlas are designed to reveal themselves to civilizations only when those civilizations reach a certain level of technological development? Think about it. If you wanted to send a message to emerging civilizations throughout the galaxy, you wouldn't make it obvious. You'd make it detectable only to species that had developed sufficient technology and scientific understanding. It would be like a test. Only civilizations that can detect and analyze an object like 3I Atlas are ready to receive whatever message or knowledge the object carries. This is the cosmic filter idea, and it's been explored extensively in SETI literature. The basic premise is that there are developmental milestones that civilizations must reach before they're ready for contact with the broader galactic community. Developing the technology to detect interstellar objects might be one of those milestones. If this is true, then 3I Atlas isn't a threat. It's an invitation. It's saying, you've reached the point where you can see us. Now you're ready for what comes next. What comes next? I don't know. Nobody knows. But the fact that we're having this conversation, the fact that we've detected this object and are asking these questions, means we've crossed a threshold. Humanity is no longer confined to looking at our own solar system. We're now players on the galactic stage, even if we don't fully realize it yet. And that brings us to the most important part of this entire discussion. Because it's not really about 3I Atlas, it's about us. It's about how this discovery changes our understanding of who we are and what our future might hold. Let me tell you about a concept called the overview effect. It was coined by author Frank White in 1987 to describe the cognitive shift that astronauts experience when they see Earth from space for the first time. When you're on Earth, you see borders, nations, differences. But from space, you see one planet, one fragile blue sphere floating in the void. Astronauts consistently report that this experience fundamentally changes their perspective on life, politics, and humanity's place in the universe. The Russian cosmonaut Yuri Gagarin, the first human in space, said after his flight in 1961, "I could have gone on flying through space forever." The American astronaut Edgar Mitchell, who walked on the moon, described his experience as an explosion of awareness and spent the rest of his life studying consciousness and human potential. Canadian astronaut Chris Hadfield said that seeing Earth from space made him realize how paper-thin our atmosphere is, how fragile our planet is. These individuals had a direct, visceral experience of Earth's place in the cosmos. For the rest of us, that understanding is abstract, intellectual. We know Earth is a planet orbiting a star in a galaxy filled with billions of other stars. But we don't feel it. It doesn't change how we live our daily lives. 3I Atlas has the potential to create a collective overview effect for all of humanity. Not by showing us Earth from space, but by showing us that we're not alone in the universe. By proving that the cosmos is filled with objects, entities, intelligences that are not us. By forcing us to confront the reality that Earth is not the center of creation, but one small part of something vastly larger. Dr. Douglas Vercook, president of MEDI International, studies the potential psychological and sociological impacts of contact with extraterrestrial intelligence. In his 2014 book, Archaeology, Anthropology, and Interstellar Communication, he explored how different cultures and societies might react to confirmed evidence of alien intelligence. His conclusion was that the impact would depend largely on how the discovery was framed. If it's framed as a threat, an invasion, humanity would unite against the perceived danger. We've seen this pattern throughout history. External threats create internal cohesion. But if it's framed as an opportunity, a chance to learn from a more advanced civilization, the reaction could be transformative in positive ways. The challenge with 3i Atlas is that we don't know how to frame it. It's not clearly a threat. It's not clearly an opportunity. It's ambiguous, mysterious, possibly dangerous, but potentially enlightening. And that ambiguity is what makes it so psychologically challenging. Humans don't handle ambiguity well. We want clear categories, obvious answers, simple narratives. Good guys and bad guys, safe and dangerous, natural and artificial. But 3i Atlas refuses to fit into our categories. It exists in the spaces between, challenging us to expand our thinking, to accept that the universe is more complex than our mental models can easily accommodate. This is uncomfortable. It creates what psychologists call cognitive dissonance, the mental stress that occurs when we hold contradictory beliefs or encounter information that conflicts with our worldview. And the typical response to cognitive dissonance is either to reject the conflicting information or to radically revise our worldview. I believe, and this is just my personal opinion, that we're at a pivotal moment. The discovery and ongoing study of 3i Atlas is forcing humanity to confront questions we've been avoiding for a long time. Are we alone? Is the universe alive with intelligence? What does it mean to be human in a cosmos that contains other minds? These aren't just abstract philosophical questions. They have immediate, practical implications for how we think about our future. If we're alone, then our choices matter on a cosmic scale. We might be the only intelligence in the galaxy, maybe in the universe. Our survival, our flourishing, our eventual spread to other worlds, all of it is crucial because there's no one else. But if we're not alone, if the universe is filled with intelligence in forms we're only beginning to recognize, then we're part of a larger story. Our choices still matter, but they matter in a different way. We're not the protagonists of the cosmic narrative. We're characters in a much longer, much stranger story that's been unfolding for billions of years. Which perspective is correct? I don't know. But 3i Atlas is pushing us toward an answer, whether we're ready for it or not. Here's what I want you to understand. The really important question isn't, what is 3i Atlas? The really important question is, what do we do with this information? How do we respond to the knowledge that our solar system is being visited by objects we don't understand? How do we prepare for a future where the distinction between natural and artificial, between alive and inert, between Earth and space, becomes increasingly blurred? Dr. Caleb Scharf, director of astrobiology at Columbia University, wrote something in 2016 that stuck with me. He said, "The universe might be teeming with life, but not life as we know it. Not biology, but something else, something that operates on different principles, uses different substrates, exists on different timescales. We might be surrounded by intelligence and not recognize it because we're looking for mirrors of ourselves. What if that's what 3i Atlas represents? Not a mirror of human intelligence, not a spacecraft built by little green men, but something genuinely alien. An intelligence shaped by conditions we can barely imagine, operating on principles we haven't discovered, pursuing goals we can't comprehend. If that's true, then our encounter with 3i Atlas isn't first contact. It's first recognition. We're finally developing the conceptual tools, the scientific understanding, the philosophical flexibility to recognize that intelligence exists in forms radically different from our own. And that changes everything. It means we need to expand our definition of life, of intelligence, of consciousness itself. It means we need to accept that the universe is stranger, more diverse, more fundamentally weird than we ever imagined. It means we need to approach the cosmos with humility, with wonder, with the understanding that we're children taking our first steps into a vast and ancient realm where the rules are different from anything we've experienced. This isn't easy. Humility isn't humanity's strong suit. We like to think we understand things, that we have it figured out, that our models of reality are accurate. But 3i Atlas is showing us that we don't have it figured out. We're missing something fundamental, and the only way forward is to admit that, to embrace the uncertainty, to accept that the universe is teaching us lessons we didn't know we needed to learn. So what do we do? How do we respond? I'll tell you what I think we should do, and I genuinely believe this is the most important message in this entire video. We need to watch 3i Atlas. We need to study it with every instrument we have. We need to gather data, analyze patterns, test hypotheses. Because regardless of what it is, whether it's a natural comet or something else entirely, it's teaching us about the universe. Every observation, every measurement, every surprising result is expanding our understanding. But we also need to prepare. Not prepare for an invasion or a catastrophe. Prepare mentally, philosophically, spiritually for a universe that's more complex than we thought. Prepare for the possibility that we're not alone. Prepare for the reality that our children or grandchildren might grow up in a world where contact with non-human intelligence is a confirmed fact. How do you prepare for something like that? You start by questioning your assumptions. Every assumption you have about reality, about life, about intelligence, put it on the table and examine it. Ask yourself why you believe what you believe. Ask yourself whether your beliefs are based on evidence or just on what you've been taught. What feels comfortable? What matches your experience? This is hard work. It's psychologically challenging to question fundamental beliefs, but it's necessary. Because if 3i Atlas is what I think it might be, if it's the vanguard of a larger revelation about the nature of the cosmos, then we need to be ready. We need to have flexible minds, open to new possibilities, capable of integrating information that doesn't fit our existing frameworks. Let me give you a practical example. Right now, most people think of space as empty, dead, hostile. It's the void, the absence of life. But what if that's wrong? What if space is alive, not with biological organisms, but with structures, patterns, processes that exhibit lifelike properties? What if the interstellar medium is a kind of ecosystem, and objects like 3i Atlas are the organisms that inhabit it? If you can wrap your mind around that possibility, even if it turns out to be wrong, you've expanded your conceptual toolkit. You've made yourself capable of thinking about the universe in new ways. And that's what we need. Not definitive answers, but better questions, more flexible thinking, greater comfort with ambiguity and uncertainty. Dr. Stuart Kaufman, a theoretical biologist who's done pioneering work on complexity and self-organization, talks about what he calls the adjacent possible. It's the space of possibilities that are one step away from your current reality. You can't jump directly to radically different states, but you can move incrementally into new territories, exploring possibilities that were previously invisible to you. 3i Atlas is opening up the adjacent possible for humanity. It's showing us new territories to explore, new questions to ask, new ways of thinking about our place in the universe. And the beautiful thing about the adjacent possible is that once you've moved into it, a whole new set of possibilities opens up beyond that. It's like climbing a mountain. Each new vantage point reveals territories you couldn't see from below. So here's my challenge to you. Don't just watch this video and move on with your life. Actually think about what I've told you. Sit with the discomfort of not knowing what 3i Atlas is. Let yourself wonder. Let yourself imagine possibilities. Talk about this with friends, with family. Share this information. Because the more people who are thinking about these questions, the better prepared we'll be for whatever comes next. And something is coming. I don't know what. Nobody knows what. But the universe has been quiet for so long, and now it's starting to speak. Objects like 3i Atlas are messages, data points, clues in a larger pattern we're only beginning to perceive. The truth is way scarier than you think, because the truth is that we don't know the truth. We're guessing. We're extrapolating from limited data. We're trying to understand the cosmos that's billions of years old and incomprehensibly vast, using brains that evolved to find food and avoid predators on the African savanna. We're massively outclassed by the complexity of the reality we're trying to comprehend. But here's the thing that gives me hope. We're trying. Humanity, for all our flaws and limitations, is genuinely curious about the universe. We build telescopes. We launch space probes. We publish papers and have debates, and gradually, incrementally improve our understanding. We're not content to live in ignorance. We want to know. And that impulse, that desire to understand, is what makes us special. Maybe we're not the only intelligence in the universe. Maybe objects like 3i Atlas represent minds or processes far more advanced than ours. But we're here. We're aware. We're asking questions. And that counts for something. Let me tell you about the Voyager Golden Record, because I think it's relevant to understanding our moment in history. In 1977, NASA launched 2 spacecraft, Voyager 1 and Voyager 2, on a mission to explore the outer solar system. But they also included something special, a golden record containing sounds and images from Earth, music from different cultures, greetings in 55 languages, sounds of nature, of industry, of human activity. The record even included the brain waves of Andruyan, the project's creative director, as she meditated on the history and future of humanity. The golden record was designed to say, we are here. This is what we're like. This is what we value. If you find this, know that somewhere in the cosmos, beings like us existed and wanted to reach out across the void to connect with you. Carl Sagan, who spearheaded the Golden Record project, said, the spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. The Voyager probes are now in interstellar space, carrying humanity's message to whatever might be out there. They'll travel for millions of years, long after human civilization has either evolved into something unrecognizable or destroyed itself. Those golden records will endure as monuments to a moment when one species on one small planet dared to. Imagine that it might not be alone. Now, here's the beautiful symmetry. We sent messages into the void, and the void is sending messages back. Objects like 3i Atlas are the universe's golden records. They're carrying information about distant stellar systems, about the nature of interstellar space, possibly about intelligence that exists in forms we're only beginning to recognize. They're saying, you are not alone. The cosmos is vast and strange and filled with things you haven't imagined. Welcome to the larger conversation. How we respond to that message will define us as a species. Do we respond with fear? With curiosity? With wonder? With the determination to understand, even when understanding seems impossible? I know what I choose. I choose wonder. I choose the belief that 3i Atlas, whatever it is, represents an opportunity to expand our minds and our civilization. I choose to see this as a gift, even if it's a challenging and sometimes frightening gift. Dr. Jill Tarter from SETI once said, "We are all made of star stuff." She was referencing Carl Sagan's famous observation that the atoms in our bodies were forged in the cores of ancient stars that exploded long before our solar system formed. We are literally made from the debris of dead stars. The iron in our blood, the calcium in our bones, the carbon in our DNA, all of it was created in stellar furnaces billions of years ago. If that's true, and it is, then we're already connected to the cosmos in the most intimate way possible. We're not observers of the universe, looking at it from the outside. We're part of it. We're the universe observing itself, thinking about itself, wondering about itself. And if objects like 3I Atlas represent other parts of the universe that have also developed the capacity for observation and thought, even if that capacity looks nothing like ours, then we're encountering ourselves in a sense. We're encountering other expressions of the same cosmic process that created us. We're meeting our siblings, our cousins, our distant relatives in the great family of matter and energy that's been evolving for 13.8 billion years. That perspective transforms the question from, what is 3I Atlas, and should we be afraid? To, what is 3I Atlas teaching us about the universe we're part of? It shifts us from a defensive posture to an open, receptive one. It allows us to approach this mystery with the curiosity it deserves, rather than the fear it might provoke. Now, let me bring this back to something concrete and personal, because I promised I'd show you how this affects your daily life, your worldview, your sense of who you are. Every human being creates a narrative about their life. We tell ourselves stories about where we came from, what we're doing, where we're going. These narratives give our lives meaning and structure. They help us make sense of our experiences and guide our choices. For most of human history, those narratives were local. Your story was about your family, your tribe, your village. Your place in the world was defined by the few dozen or few hundred people you'd encounter in your lifetime. Then human civilization expanded. Empires rose. Trade routes connected distant lands. Your narrative expanded to include your nation, your culture, your place in history. You were part of something larger than your immediate community. In the 20th century, we developed a global perspective. Television, the internet, global travel, all of it connected us. Your narrative now includes the entire human species. You're aware of events happening on the other side of the planet. You can communicate with people in different countries, different cultures. You're part of a global civilization. Now, in the 21st century, we're developing a cosmic perspective. We're learning that Earth is one planet among billions in our galaxy, which is one galaxy among trillions in the observable universe. We're detecting objects from other stellar systems. We're finding exoplanets that might harbor life. We're confronting the reality that our narrative needs to expand again, to include not just all of humanity, but our place in a vast, ancient, complex cosmos. This expansion of narrative is destabilizing. It challenges your sense of importance, of meaning, of purpose. If the universe is so vast, and we're so small, does anything we do matter? If intelligence exists elsewhere, possibly in forms far more advanced than ours, are we special at all? These are the questions that 3I Atlas forces us to confront. And I'm going to be honest with you. The answers aren't comforting in a traditional sense. No, you're not the center of the universe. No, humanity isn't the pinnacle of cosmic evolution. No, our existence isn't cosmically significant in the way ancient religions taught us to believe. But here's what is true, and this is important. You exist. Against incomprehensible odds, you exist. The particular configuration of atoms and energy that makes up you, your consciousness, your experiences, your thoughts, exists right now in this moment. And that's extraordinary. Think about it. The universe is 13.8 billion years old. It's filled with countless galaxies, each containing billions of stars. Most of space is empty, cold, lifeless. Most matter exists as gas clouds or rocks or radiation. But some tiny fraction of the universe's matter has organized itself into structures complex enough to be aware of their own existence. To think, to wonder, to ask questions about 3I Atlas and what it means. You are one of those structures. You're a pattern of matter and energy that has become conscious. And that consciousness allows you to participate in a universe's ongoing process of understanding itself. When you look at 3I Atlas through a telescope or watch a video about it, you're engaging in an act of cosmic significance. You're part of how the universe learns about itself. The atoms that make up your brain, forged in ancient stars, are now processing information about an object from another star system. You're a bridge between two stellar neighborhoods, separated by light years, but connected through the medium of your consciousness. That's not insignificant. That's profound. Dr. Brian Swim, a mathematical cosmologist who studies the philosophical implications of modern cosmology, talks about what he calls the universe story. He argues that the universe has been evolving for billions of years toward greater complexity, from simple particles to atoms to molecules to stars, to planets, to life, to consciousness. And now that consciousness has reached the point where it can understand its own origins and place in the cosmos, you're the culmination of 13.8 billion years of cosmic evolution. You're what happens when hydrogen, given enough time and the right conditions, becomes curious about itself. And right now, you're using that curiosity to understand 3I Atlas, which might represent another branch of that same cosmic evolutionary process. This perspective doesn't diminish your significance. It amplifies it. You're not separate from the cosmos. You're an expression of it. And your choices, your thoughts, your responses to the mystery of 3I Atlas, all of it is part of how the universe continues to evolve and understand itself. So when I say the truth is way scarier than you think, I mean it in 2S. N says, yes, it's scary because 3I Atlas challenges everything we thought we knew about our place in the universe. It's scary because we don't have answers, only more questions. It's scary because the universe is revealing itself to be stranger and more complex than our minds can easily grasp. But it's also scary in the way that standing at the edge of the Grand Canyon is scary. You feel small. You feel the vastness. You feel a kind of existential vertigo. But you also feel awe. You feel wonder. You feel privileged to witness something so magnificent. That's what 3I Atlas offers us. Not comfort, not certainty, but the opportunity to experience genuine awe at the strangeness and complexity of reality. Let me tell you about a conversation I had with Dr. Sarah Seeger, a planetary scientist at MIT, who's one of the world's leading experts on the search for life on exoplanets. I asked her what she thought would happen if we definitively confirmed that an object like 3I Atlas was artificial, created by an alien intelligence. Her answer surprised me. She said, in some ways, that would be the easy answer. If it's artificial, we can study it as technology. We can try to reverse engineer it, understand its purpose, maybe even communicate with whoever made it. The harder answer, the one that would really challenge us, is if we confirm that it's natural, but operating on principles we don't understand. Because then we'd have to accept that nature is far more creative and complex than we ever imagined. I've thought about that a lot. We're so focused on the question of whether 3I Atlas is artificial that we're missing the deeper point. Whether it's built by aliens or shaped by natural processes, it's teaching us that the universe contains possibilities we hadn't considered. It's expanding the boundaries of what we think is possible. And here's what that means for you, personally, in your daily life. If the universe can surprise us this profoundly, if something as fundamental as our understanding of comets and interstellar objects can be appended, then what else might we be wrong about? Maybe consciousness isn't confined to biological brains. Maybe life can exist in forms we haven't recognized. Maybe intelligence isn't a binary state, but a spectrum that includes everything from bacteria to humans, to ecosystems, to planets, to objects traveling between stars. Maybe the universe itself is a kind of mind, thinking thoughts on timescales of billions of years. These aren't just abstract philosophical ideas. They have practical implications. If we accept that reality is more fluid and strange than we thought, it opens up new possibilities for how we live our lives. You don't have to accept the limitations you've been taught. The boundaries between possible and impossible aren't as clear as they seem. The story you tell yourself about who you are and what you can accomplish, that story might be too narrow. Just as humanity's story about its place in the universe has been too narrow. 3i Atlas is teaching us to think bigger, to question more deeply, to remain open to possibilities that challenge our comfortable assumptions. And you can apply that lesson to every aspect of your life. Are you stuck in a career that doesn't fulfill you because you believe that's just how things are? Maybe it's not. Are you accepting limitations on your relationships, your creativity, your potential, because that's what society taught you? Maybe you shouldn't. Are you living a smaller life than you could be because you've internalized narratives about what's realistic, what's achievable, what's possible for someone like you? Maybe those narratives are wrong. The same universe that created 3i Atlas created you. You're made of the same stuff. You're subject to the same physical laws. And if the universe can create objects that blur the line between natural and artificial, between alive and inert, between purposeful and random, then you're capable of far more than you've been led to believe. I'm not saying you can violate the laws of physics. I'm saying that the laws of physics permit far more strangeness, far more complexity, far more possibility than our limited human perspectives usually acknowledge. And when you internalize that, when you really understand that the universe is weirder and more open-ended than you thought, it changes how you approach everything. You become more willing to take risks, more willing to explore ideas that seem crazy at first, more willing to question authority and convention and the way things have always been done. Because if astronomers with PhDs and decades of experience can be fundamentally wrong about the nature of comets, then maybe everyone else is wrong about a lot of things too. This is the real gift of 3i Atlas, not the specific scientific data it's providing, though that's valuable, but the permission it gives us to think differently, to imagine more expansively, to question more fearlessly. Now I want to address something that some of you might be thinking. This is all very interesting, but what difference does it make to my life? I've got bills to pay, problems to solve, a life to live. Whether or not some comet from another star system is natural or artificial doesn't change any of that. And you're right. In one sense, 3i Atlas doesn't change your immediate daily reality. You still have to go to work tomorrow. You still have to take care of your responsibilities. The practical, immediate concerns of life continue regardless of cosmic mysteries. But here's what I've learned from studying transformative moments in history. The things that seem most distant and abstract often end up having the most profound practical impacts. Just not immediately. Not in obvious ways. When Copernicus proposed that Earth orbits the Sun rather than being the center of the universe, it seemed like an abstract astronomical idea with no practical implications. But it fundamentally changed how humans thought about their place in the cosmos. That shift in perspective eventually contributed to the scientific revolution, to the Enlightenment, to the modern world you live in today. Your smartphone, your medical treatments, your political freedoms, all of them trace back in part to that moment when we stopped believing we were the center of everything. When Einstein developed the theory of relativity in 1905, it seemed like pure abstract physics with no practical applications. But without relativity, GPS satellites wouldn't work. The device in your pocket that tells you how to navigate to the grocery store depends on Einstein's equations accounting for the way time dilates in orbit. When quantum mechanics was being developed in the 1920s and 1930s, it was a bizarre, counterintuitive theory that seemed to have nothing to do with everyday life. But quantum mechanics gave us transistors, which gave us computers, which gave us the internet, which has transformed every aspect of modern existence. The pattern is clear. Today's weird, abstract, seemingly irrelevant scientific discovery becomes tomorrow's transformative technology or philosophical framework. The insights that seem most distant from practical concerns often end up reshaping civilization in ways no one predicted. So when I tell you that 3I Atlas might be artificial, or might be a space organism, or might be something we don't have concepts for, I'm not just sharing interesting trivia. I'm telling you about a potential inflection point in human history. A moment when our understanding of reality shifts, and that shift ripples outward to affect everything. If we confirm that 3I Atlas is artificial, the implications are staggering. It means we're not alone. It means interstellar travel is possible. It means there are civilizations out there with technology far beyond ours. That knowledge will change our priorities as a species. It will influence how we allocate resources, what scientific questions we pursue, how we think about our future. Maybe we'll unite as a planet, realizing that our differences are trivial compared to the fact that we're all humans facing a universe that contains other intelligences. Maybe we'll pour resources into space exploration, desperate to understand the context we're operating in. Maybe we'll develop new technologies, inspired by studying 3I Atlas, technologies that transform life on Earth in ways we can't currently predict. Or maybe we'll fracture, with different nations and groups interpreting the discovery in conflicting ways. Maybe some will see it as a threat and demand military responses. Maybe others will see it as a religious revelation. Maybe the ambiguity of not knowing exactly what 3I Atlas is will create more problems than it solves. I don't know which way it will go. Nobody does. But the point is that this discovery, this moment we're living through right now, has the potential to be historically significant. And you're here for it. You're witnessing it. You have the opportunity to be part of the conversation, to think about these questions, to help shape how humanity responds. That's not abstract. That's deeply, profoundly relevant to your life. Because the choices we make in the next few years about how we study 3I Atlas, how we interpret the data, how we communicate with the public about what we're finding, those choices will shape the world your children and grandchildren inherit. Let me bring this toward a conclusion by talking about hope. Because despite everything I've told you, despite the uncertainty and the strangeness and the things we don't understand, I'm fundamentally hopeful about what 3I Atlas represents. Here's why. For centuries, maybe for our entire existence as a species, humans have looked at the stars and wondered if we're alone. That question has haunted us. It's driven our mythology, our religions, our science fiction, our space programs. Are we the only consciousness in the universe? Are we the only ones asking questions, creating meaning, trying to understand? The loneliness of that possibility is crushing. The responsibility is overwhelming. If we're alone, then consciousness itself is so rare, so precious, so fragile that its extinction would be a cosmic tragedy. If we destroy ourselves, either through war or environmental collapse or some other catastrophe, then the universe loses its only known method for understanding itself. But 3I Atlas suggests we might not be alone. Whether it's artificial or natural, whether it represents technology or evolved adaptation, it's evidence that the universe creates complexity, creates structures that respond and adapt and persist across cosmic timescales. We're not the only surprising thing the universe has produced. That takes some of the pressure off. We're still responsible for our own survival, our own choices. But we're not carrying the entire weight of cosmic consciousness on our shoulders. We're part of a larger process. And that's comforting in a way. More than that, it means the universe is alive with possibility. If one interstellar object out of 3 exhibits signs of complexity we don't understand, imagine what else is out there. Imagine what we'll discover in the next decade, the next century, the next millennium as our technology improves and our understanding deepens. We're at the very beginning of the story. We're in the opening pages of humanity's cosmic adventure. And 3I Atlas is showing us just how incredible that adventure is going to be. Dr. Frank Drake, who developed the famous Drake equation for estimating the number of communicative civilizations in the galaxy, said something toward the end of his life that stuck with me. He said, "The search for extraterrestrial intelligence is really a search for ourselves. We're trying to understand what we are, where we came from, whether we're unique or common. And regardless of what we find, the search itself ennobles us. It represents our highest aspirations as a species. 3i Atlas is part of that search. And the fact that you're watching this video, thinking about these questions, engaging with these ideas, means you're part of it too. You're participating in humanity's effort to understand itself and its place in the cosmos. That's not a small thing. That's heroic in the truest sense of the word. So here's what I want you to take away from this. The universe is stranger than you imagined. Reality is more fluid, more complex, more surprising than the stories you were told. Objects like 3i Atlas are shattering our comfortable assumptions and forcing us to think in new ways. That's scary. But it's also exhilarating. It's permission to dream bigger, to question more deeply, to imagine more expansively. It's an invitation to participate in the greatest adventure humanity has ever undertaken, the quest to understand the nature of reality itself. And you don't have to be a scientist to participate. You just have to be curious. You just have to be willing to sit with uncertainty, to ask questions, to wonder. Because that curiosity, that willingness to engage with mystery, is what makes us human. It's what makes us worthy of being part of the cosmic story. In June 2026, if current trajectory calculations are correct, 3i Atlas will reach its closest approach to the inner solar system. Every major telescope on Earth and in orbit will be pointed at it. Teams of scientists will be analyzing every photon of light it emits, every subtle change in its trajectory, every piece of data we can extract. And we'll learn something. Maybe we'll learn that it's just a comet after all, weird but explicable within our current understanding of physics and chemistry. Maybe we'll learn that it's something else, something that forces us to revise our theories and expand our categories. Maybe we'll learn that the universe has been trying to tell us something all along, and we're finally ready to listen. Whatever we learn, it will be significant. It will change us. And that change will ripple outward through our civilization in ways we can't predict, but can certainly anticipate will be profound. I started this video by telling you that the truth is way scarier than you think. And it is. The truth is that we don't understand the universe. The truth is that objects from other star systems are visiting our solar system and exhibiting behaviors we can't explain. The truth is that everything we thought we knew about our place in the cosmos might need to be reconsidered. But there's another truth that's equally important. You're here for this. You're alive during a moment when humanity is expanding its understanding of reality in fundamental ways. You get to witness the mystery. You get to participate in the wondering. You get to be part of the conversation about what it all means. That's a gift. It's a terrifying, challenging, uncomfortable gift, but it's a gift nonetheless. So keep watching the skies. Keep asking questions. Keep wondering. Because the universe is revealing its secrets, slowly, piece by piece. And each revelation makes us more than we were before. Each mystery we encounter expands our capacity for understanding and wonder. 3i Atlas is out there right now, moving through our solar system, carrying with it information about the nature of reality that we're only beginning to decode. It's a message from the universe, and the message is simple. You are not alone. The cosmos is alive with strangeness, and you, improbable, conscious, curious you, are part of it. Welcome to the universe. It's weirder than you think, and that's exactly how it should be. If this video changed how you see the universe, hit that subscribe button. Share this with someone who needs to have their mind expanded. And leave a comment telling me what you think 3i Atlas really is. Because this conversation, this collective wondering, is how we move forward together into a strange and magnificent future.